So we do start our subject. So I request everyone to mute yourself. When you got any question, you can unmute and you can ask. So on the screen, you are able to see certain diagrams. So first, we are, please mute, all students, please mute yourself. Yes.
Sir, can you share the link to yesterday's class again?
Already in chat box I kept. Already in the chat box I kept. You can check that one. Okay. Now all the students focus a lot, and I request to mute yourself. Okay. Now, so K. Raviteja is belonging to CSC only. K. Raviteja. And please mute and unnecessary. See, we are not supposed to leave it. Yeah, okay, right. So please mute all of you, those who are unmuting. Right. So the very first topic which we are supposed to start in BW subject is the definition of current. So if you ask any person define current, they say flow of electrons, flow of charges. Okay, but it is 100% wrong answer. So how to explain the current definition? So first we are supposed to study this particular conductor. So first we must start our explanation with the conductor. So on the screen, you are able to see one particular rod. Only one student raise your hand and confirm. The screen has been changed. You are able to see one particular rod, copper rod. Yes, okay, right.
Yes, sir.
Okay, right. Thank you. So now, from where we have to start our subject application. As I mentioned in BW, we calculate the currents. Okay. So where the currents will flow? Current flows through the conductor. So this is best example of conductors are copper and aluminium. So we are taking one copper rod or copper wire. So what happens inside the copper rod is what we are supposed to discuss. So copper rod or copper wire you can purchase from electric shop. So our favorite shop is nothing but electric shop, the BW subject. Okay, so whatever we discuss, we can purchase from the electric shop and we can do the experiments at our home. Okay, now this is the rod and current flows through the rod. So first we must explain in what way the current flow. So imagine this, this is nothing but rectangular, whatever the rectangular structure you are seeing. Let us concentrate on this one first. So we assume that inside the conductor example is copper. Okay, inside the conductor we are having the electrons. So forget about the protons, nuclear model, Bohr's atomic model. We are not discussing the physics. We are into the calculation of the current. So we must assume first. So inside the conductor, okay, we are having the electrons. So electrons, any one student, once again, please see the image and tell me, electrons are moving or they are static? Raise your hand and just confirm. Yes, come on. Electrons are in this image. Yes, go ahead. Shreya, you please can go ahead. Yes, see the image and tell me. Electrons in this image are constant or they are moving? Anyone, any other student?
Constant.
Constant, very good.
Constant.
So now, if naturally, if I take one particular conductor, inside that conductor, we are having n number of electrons, maybe 100 or 20 or 30. But all these conductors, all these electrons, they are not having the energy to move from one place to another place. If electrons are moving from one place to another place, then we say current flows through the conductor. And if I connect one bulb, bulb is on. So what's going to happen? Initially, electrons are not having energy to move from one place to another place. Electrons are static. So what we do, we connect this particular conductor to a battery. So from the battery, we get the energy. So when battery is connected to this one, battery is connected to this particular conductor, electrons receive the energy from battery and they start to move from one place to another place. Now let us show this one. Yes, now all the students, I hope the animation is playing now. Now first concentrate on this particular image which I am showing. So electrons initially, in the absence of voltage, from the battery we get the voltage. Remember first, okay? So this image animation you have to supposed to concentrate. So with the application of the battery or with the application of the voltage, so, right. With the application of the voltage, what's going to happen? Electrons receive the energy and they start to move from one place to another place. So initially, if you see, all electrons are placed in an order. No. When battery is given to this particular conductor, okay. So what is the definition of current we are discussing right now? So first, current flows when you are connecting the battery. Okay. Current is what your definition? The flow of, now you see all of you, electrons, all the electrons. Now you see this particular animation, the third one. Electrons in the presence of supply, electrons are moving in a uniform direction or straight direction. They are not moving. You see the top image, here the electrons are moving in random direction or the zigzag direction. So electrons are supposed to move only in a uniform direction or straight direction. Then we say it is called the current. So the flow of, now here also we are supposed to assume one condition. So if you take a conductor, inside the conductor we are having electrons. Electrons initially cannot move from one place to another place. So with the application of voltage, electrons receive the energy. Say, please mute everyone. Okay, don't unmute and we are getting unnecessary disturbance. With the application of voltage, electrons gain the energy and they start to move from one place to another place. Now you can see electrons are all moving in a uniform direction, in a straightforward direction with the application of voltage. So when I apply the voltage, if I am having 100 electrons, all the 100 electrons cannot receive the energy. Out of 100, 90 or 99 or only 10. They can receive the energy, they can flow from one place to another place. Therefore, the electrons which receive the energy and travel from one place to another place are called free electrons. So wherever you go, you must explain the flow of free electrons, not just the electrons. So if I'm having 100 electrons, few electrons cannot receive and they cannot move from one place to another place. So the electrons which are moving from one place to another place or which are taking part in the conduction are called the free electrons. Now all of you, electrons contain negative charge. So electrons are repelled by negative polarity or negative terminal of the battery and they are attracted towards the positive terminal. So always electrons flow from which terminal to which terminal? Electrons flow from negative terminal to positive terminal. Electrons flow from negative terminal to positive terminal. Now I am giving the definition of the current. Okay. What is the definition of current? The flow of which electrons? Anyone student tell me? Flow of, can I say directly electrons? No. The flow of free electrons. Okay. Free electrons. So if I give the voltage, all 100 electrons cannot move from one place to another place. Only few electrons will move. Those electrons are called the free electrons. The flow of free electrons in a uniform direction, in a systematic manner, in a uniform direction, in a closed path. You see everything is closed here. So if current cannot flow through the air, say anywhere any circuit is open, then current is equal to 0. So I hope all students now you have understood. Inside the conductor, we are having the electrons practically, and these electrons are static. When you apply certain battery or voltage, the electrons gain the energy and they start to move from one place to another place in a uniform direction. Okay, so remember all of you, the flow of free electrons in a uniform direction in a closed path. Closed path means it should be entirely closed circuit. Okay, it is called the current. The flow of free electrons in a uniform direction. Here the direction is important. In a uniform direction in a closed path is called the current. Okay, now one more definition of the conventional current. One more definition. Second definition is, what is conventional current? Conventional means it is a rule. So listen carefully, all of you. Many students will get confused with which terminal. Current always flows from which terminal to which terminal. Okay, that is the question. Now first, let us be confident with the definition of the current. Any one student, please tell me the definition of the current. Raise your hand and tell me. The flow of free electrons.
Flow of free electrons uniform direction in a closed path is called current.
Current. Very good. Very good. Okay, right. Thank you. So the flow of free electrons in a closed path in a uniform direction is called the current. Okay. Now, till now, nobody has created this phenomenon. That is, without battery, you cannot move the electrons. So what is the voltage definition we are taking now? As I mentioned, our subject deals with calculation of the currents. So if voltage is not present, current cannot flow. In your house also, one simple question I'm asking. When you turn on the switch, immediately voltage is created across the switch. Yes, Vaishnavi, you have raised your hand. Please tell me. Okay. In your house, when you are turning on the switch, first voltage will be created, and when wires are connected, then current flows through the wire. Okay. Now, what is the definition of voltage? We are having a number of definitions. V is equal to IR from Ohm's law. But now you see, voltage is the energy given to the electrons to make the electrons to move from one place to another place. Voltage is the energy given to the conductor or electrons. We can also say in this manner, voltage is the energy given to the electrons to make the electrons to move from one place to another place. So, sir, show me the voltage means you buy the battery. Battery contains positive terminal and negative terminal, and that battery generates the voltage. So voltage is the energy given to the electrons to make the electrons to move from one place to another place. And remember, always electrons will flow from negative terminal to positive terminal. Electrons are repelled by negative polarity or negative terminal. They travel from negative terminal to positive terminal. Terminal means end point terminal. Okay. So remember all of you, electrons always flows from negative terminal to positive terminal. Okay. Now, so all engineers throughout the world, they came up with one definition, which is assumption that current is flowing. Really, current will flow? Current cannot flow. Current is the imagination of the engineers, that word. Actually, electrons will flow through the wire. So if somebody asks you how many electrons are flowing, we cannot see with our eyes. But if I am having the sensors, those sensors will prove us practically that certain electrons are flowing through this particular conductor. So that's why we are supposed to assume and we are supposed to go with this explanation. That is what the engineering here. Now come to the next word. Current is not really existing. Actually, electrons are flowing through the wire. Electrons flow through the bulb. Okay, electrons flow through the fan. But all the engineers, they came up to one particular assumption or convention. Convention means it is a rule everyone has to follow. So what is that convention? Current. This is, please mute, don't unmute. If you got the question, you please unmute and ask. Okay, follow the instruction. Now this is the conventional current. What is a convention? It is a rule. All engineers, they came up to one particular rule that in any circuit, what is a circuit? See all of you, battery, bulb and wires. It is called circuit. Simple, battery, bulb. So everywhere we say electrons are not flowing, we use the word current flows through the wire. Current flows through the bulb. So how the current will flow? Always direction of current is assumed to the opposite to the direction of movement of electrons. If you see, here electrons are moving from negative terminal to positive terminal. But if I'm writing in my examination or if I'm drawing any circuit, we are assuming that current flows from which terminal to which terminal. You can see this animation, last animation, current starts from positive terminal and current flows through this particular entire wire and come back to the negative terminal. Now these are electrons, and here they are showing the animation of the current. Many people will get confused here. So in the books, they show that the current starts to flow from positive terminal to negative terminal, which is entirely assumption of the engineers. So we are supposed to use this rule. So draw from positive terminal to negative terminal. So in any circuit or in your house also, if you turn on the bulb, current starts from positive terminal, current flows through the wire and current flows through the bulb, and current will flow through the, come back to the negative terminal. Sir, what is this? This is the assumption. So what's happening practically? Electrons will move from negative terminal to positive terminal. So this is what the first basic everyone should understand, because we are supposed to do the problems. Okay. So electrons move from negative terminal to positive terminal, which we are not going to represent while we are calculating the circuits current. So current always flows from positive terminal to negative terminal. Is it really happening, or is this the imagination? Anyone student, raise your hand and tell me. Current is really flowing through the wires? It is the?
No, sir.
No, it is the imagination of the all engineers that current flows from positive terminal to negative terminal. Okay, that current is called, the current which always flows from positive terminal to negative terminal is called conventional current. So for BW class, one book or one notes or one paper you have to keep, you have to write at the time of explanation. Okay, so these definitions. So current, the flow of free electrons in a uniform direction in a closed path is called current. Okay. So I am confident you can compare with your friends, others out studying also. Many people will say flow of electrons. Where they are flowing? They are flowing through air? No. The flow of free electrons in a uniform direction in a closed path is called the current. Okay. So what is this conventional current? Conventional current is the imagination of engineers, which is flowing always from positive terminal to negative terminal. Okay, all of you, right? This is the basic difference between the current and the conventional current. Many textbooks, they write current is flowing from positive terminal to negative terminal. It is
Sir,
also,
tell again the definition, sir.
yeah. See, definition I will show you on the screen also. You can take the screenshot or you can write. Okay. First you see conventional current.
Okay,
always,
sir.
Conventional current always flows from positive terminal to negative terminal. Okay. So first let me show you the definition. Now you see here, if I am having number of electrons maximum current will be created. So I'll go back to this one. Now here I kept here. You are asking for definition now. So it is visible now, all of you. What it is written? One student, unmute and read out. Only one student. Raise your hand. And flow of
The flow of free electrons in a closed path in a uniform direction
is called current. It's called current. Okay, all of you, right? So where the current will flow? Current will flow through the stone? No, current cannot flow through the stone. That means periodic table. You are having the periodic table where all the elements are arranged in an order based upon their property, behavior. Many scientists every day, they take the stones, sand, and they test whether we are passing the current, electricity or not. That is what important. So best conductors still now all over the world is copper and aluminum. So this is the copper rod or copper wire. In our house, we are using the copper wires only. Okay. And near the pole, you are having those lines. There we are using the aluminum. So the flow of electrons in a closed path in a uniform direction is called the current. So everything is happening inside this particular copper rod. Okay. This is what we are supposed to remember. And remember, in examination, nobody will ask you define current. Okay, interviews and when you go for outside also, but you must know the basic thing. Okay, the flow of free electrons in a closed path in a uniform direction is called the current. So now, the first introduction, you have taken the current. Even voltage battery is not connected, all electrons are constant here. Okay, so when battery is connected, electrons gain the energy. So this explanation, I will not repeat. Last time I'm repeating. You have to remember, you have to write in your own words. Okay. explain the current. So everybody can write the definition. But you remember, you must be separate from the other students. So inside a conductor, we are having the electrons. These electrons are static. They are not having energy to move from one place to another place. Therefore, when a battery is connected to the conductor, electrons gain the energy, electrons receive the energy, and they travel from one place to another place. Only few electrons can understand the battery and they try to move from one place to another place. These electrons are called free electrons. The flow of free electrons in a uniform direction in a closed path is called the current. Okay, right. So every material also will be done. Now let us move to the next one. Okay. So now I'm just sharing this one. Everyone, is it okay? The current. Okay. So
No,
before
sir.
not understood. Anyone? Yeah, I'll repeat that one. Please say.
Yes, sir, not understood.
Not understood. Okay, right. You just see, all of you. What is the definition of current? The flow of free electrons. You see,
Electrons.
free electrons.
Of free electrons.
The flow of free electrons in a closed path in a uniform direction is called the current. So already we kept the definition here. Okay, right. Just a minute. So the students who have not understood, so no need to write at the time of listening. Just listen, and this video link will be shared, and then you can write the certain words, and I am going to release the material. In that material, everything will be there as per the examination. Okay. So for time being, what is the definition of current? The flow of free electrons in a closed path in a uniform direction is called the current. Okay. So conventional current always flows from positive terminal to negative terminal. Now all the students, now let us go back to this particular. After definition of current, let us see what is our aim. So every student, you can take the screenshot of this one, BW subject. Anyone can read out what is a new thing we have added today. The third statement. Already I mentioned.
B.
About generating
Yesterday one student asked, what is the full form of BW? Basic Electrical and Electronics Engineering. Okay. And that is how you are going to use the electrical and electronic engineering for software people. So all students now. So already I mentioned, in order to calculate the current, we should know what is the in-depth explanation of the current. So now, BW is all about what? Here, what we can do with BW subject? All students, we can generate which energy? Magnetic energy.
Magnetic energy.
So remember my word here. Yes. So simultaneously, you have to feed the explanation into your brain, and you can. Magnetic energy is the only energy which can oppose the gravitational force and make the objects to fly in the air. So please mute. Yes. Magnetic energy is the only energy which can oppose the gravitational force and can make the objects to fly in the air. So we'll discuss that one. So now next explanation, we are just after definition of current, we are going to study how we generate the magnetic energy. See, material, no need to worry. All of you first listen, and what you are understanding, you put it on the paper. Okay, right. So our next target is nothing but how to generate the magnetic energy. Sir, what is the use of magnetic energy? We'll see now. So first, let me share the new slide, all of you. Now any diagram is there, you can take the screenshot. Later on, you can draw. So first, this is important. What we are starting right now, after definition of current, the new slide you are going to see on the screen. Slowly, I am going to give the explanation. Ready now, all of you? Now one simple question I'm asking. In your house, you are having the fan. Okay, I'll start with this one. All students, now you concentrate. This animation first we'll see this one. So whenever current flows through a wire, conductor, this horizontal line is called the conductor or copper wire. Just now, which I have shown you initially. So this is the copper wire or conductor. Whenever current flows through the conductor, Now already we have assumed what is the definition of current. Okay, current flows through the conductor. Okay, current is flowing through the conductor. When current flows through the conductor, when current passes through the conductor, magnetic energy is created. Magnetic energy. So how we can draw that magnetic energy? We can draw by a circular shape. So these circles are indicating that certain amount of magnetic energy is created whenever current flows through the conductor. Is it clear, all of you? Everyone has to understand natural thing is nothing but whenever current flows through the conductor, magnetic energy is created. Is it clear? Anyone, student? Whenever current flows through the conductor.
Clear, sir.
Okay, copper, I am purchasing copper wire. Okay, I am passing the current, battery I am connecting. Okay, whenever current flows through the conductor, magnetic energy is created. Okay, now, okay, I will show you the proof also, magnetic energy, how it will be created. So now we say we are going for the modification. So I want to create, yes, these circles are nothing but, we are showing this one. I cannot draw every time conductor. So I am showing that conductor is this small circle, and when current flows through the conductor, magnetic energy is created, which is shown by the arrow marks. See, all students, please mute yourself. All right. And no need to worry and remove from your brain, sir, what we have to write in the examination for 1 week, all of you. All these are nothing but the introduction. So what we have to write in the examination, that notes I will give you. So now with free brain, you listen this explanation, remember as a practical knowledge. Yes, raise your hand, Shreya, please go ahead. What is the question?
Sir, those are magnetic fields. Those are anti-clockwise.
Yes, yes, anti-clockwise. Very good. Naturally, they rotate in anti-clockwise. We'll come each part slowly. They are anti-clockwise. So all students, okay, whatever we are doing right now, it is the introduction classes of each component. Okay. So what, when I'm giving the material, it will be directly proportional to your examination in a relaxed mode. Now you see, we are saying that copper wire I'm having, when current flows through the copper wire or the conductor, magnetic energy is created. So for your understanding, I'm sharing one more thing. Now you come to the new slide first. So everybody might have seen the magnets which are black in color. Okay, magnets, they generate magnetic energy. So this is the magnetic energy. Always magnetic energy travels from North Pole to South Pole. So this magnet's lifetime is very much less. So what we have to do, we have to take one copper wire. Okay, we have to take the copper wire, and when current flows through the copper wire or copper rod, magnetic energy is created. So I cannot draw the diagram every time. So what we can do, we can show by circles. Understood? It is not compulsory to show only 4 circles. One more diagram I'll show you. Now you see. All of you might have seen this green color. Now it is clear, I think, for all the students. So current is flowing through the conductor. When current flows through the conductor, magnetic energy is created. It is shown circular in shape. Is it clear, all of you? So whenever current flows through the conductor, which energy is created? Magnetic energy. Sir, what is the difference between magnetic field and magnetic energy? I will tell you later on. Okay. So first, we are under the impression that I am taking one particular copper wire. Okay, copper wire, and when current flows through the copper wire, magnetic energy is created. Okay. Now we are extending that this explanation, practical thing. See, whatever the theory words you are seeing here, you have to make a note of that one. Current definition I have shown you, flow of free electrons, that you have to remember. You can write, or that you can write in the notes, or you can remember. And next definition I am showing. The next one is nothing but, I want to create maximum magnetic energy. I want to create maximum magnetic energy. So what I have to do, you take this copper wire and rotate this copper wire in circular shape. All of you see, these are the examples. If you go and ask in the in the electric shop, they will give you this one. Okay, for 10 rupees you can purchase. So all are in circular shapes, copper wires. So one, yes. See, if I'm having a simple straight long copper wire, I cannot create maximum magnetic energy. if I want to create maximum magnetic energy, copper wire must be rotated in the form of a circular shape. So now you read this definition. All students, you can write this one. Remember, a copper wire, which is also called as conductor, is twisted or rotated in the form of a circular shape or coil, forms a basic inductor. In intermediate, you might have studied inductance, conductance, capacitor, inductor. Now we have written the how to manufacture the inductor. Go to electric shop. For 10 rupees, they will give you copper wire, and take that copper wire, rotate that copper wire in the circular shape. When a copper wire is rotated in the form of a circular shape, it is called as the inductor. Sir, why the name? What is the use of rotating? When you rotate a copper wire in circular shape, if current flows through that wire, maximum magnetic energy is created. So now I'm showing you this particular slide. Now all of you. Now second one, you see all of you. This is the copper wire. Okay, when these arrow marks are explaining that when current flows through the copper wire, these circles are nothing but magnetic energy is created. So if I rotate the copper wire in the circular shape, then it is nothing but we can create maximum magnetic energy. So let me try this one. All of you. Now you can see whenever current flows through the copper wire which is rotated in the form of circular shape, then maximum magnetic energy is created. I will tell you what is the use of creating maximum magnetic energy. Okay, so now just a minute. That's why now. Okay, maximum magnetic energy. Now all the students, one simple question you can ask, sir, why I have to rotate the copper wire in the circular shape? Why I have to rotate? I will rotate in diamond shape, okay, rectangle shape. Now one question I'm asking, in your house, all of you, raise your hand and answer. One student is enough. Fan you are having, fan wings you remove, and tell me what is the shape of the fan. As Prasanna, answer. What is the shape of the fan in your house? Remove the wings. Any question you got?
Circle.
Round.
Circle shape. Good. One more student I'm asking. Okay. Mixie. Mixie, how it will be there? Mixie. Anyone raise your hand? Come on, go ahead. Answer.
Circle.
Circle shape. If you see, and
It
one more
rotates
thing.
round.
Yeah, yes, very good. Rotates. And one more question. In your house, boring pump, boring machine, or water pump, how they are? They are in which shape? Circle shape. Okay, right. Mute yourself. Mute yourself, all of you. Yes, circle shape. And washing machine also, outside it might look in different shapes. But yes, go ahead. Question is there, you can ask. Washing machine also, it is in circular shape. So whatever the objects we use in our day-to-day life, they are practically circular in shape because they work with dash energy. Anyone tell me? Washing machine, fan.
Magnetic energy.
Very good, very good. So if
Magnetic
I am
energy.
magnetic energy, so BW subject is everywhere in your house. So you can see the meter also, the meter which is there in your house, energy meter. Inside that one also we can find the copper wire rotated in the form of a circular shape. So if you see in electric shop, it will be like this. But every time we cannot draw in our books a huge circle shape. So this is the symbol of the inductor. This is nothing but, the meaning is nothing but, it is already understood that copper wire is rotated. Okay, you can place n number of turns here, like this 5 or 6, it is up to you. So now we say, here I am showing the battery, switch will be on and off. Okay, when battery is on, current starts from the battery, current flows. This is called which current, anyone? The current which always flows from positive to negative terminal is called conventional current.
Conventional
Yes,
current.
when battery is on, yes, when battery is on. See all the students, less than 1 minute is there. Shall I continue the class with the link? Tell me openly.
Yes, sir.
No
Yes,
problem,
sir.
all the
Yes,
students. Because I am taking the core explanation here of our engineering subject. Okay. If the link get disconnected, you relog in. No need to worry at all. Okay. So when the battery,
Okay, sir.
yes, and yes, please mute. when the battery is on, current flows through the wires, and current flows through this particular copper wire rotated in the form of circular shape, and huge magnetic energy is created. So with the creation of magnetic energy, I can develop the robots, I can develop the fan, induction stove. Why the name induction? Induction means the copper wire is rotated in the form of a circular shape. So whenever copper wire is rotated in the form of circular shape,